we are going to do the hypothesis testing again. Since we learned that previously, 5 steps hypothesis testing. So it's not that new to us. The only new part here is the environment. We are going to change a little bit. So if you remember, previously, when we do the hypothesis testing, right, we always like remember H0 is like always equal. Like most of the time, average mu is equal to some number, or proportion P is equal to some number. That's what we have done before, right? And for the H1, remember we have dealt with the 3 situations. Is that bigger than, or is that less than, or is not equal to? That is 2-sided test, right? So that's what we have done in the past. In chapter 9, we are going to learn something a little bit different. So we are going to use some example here to understand when we say compare to average. What do we mean by that? So this example here, let's see. So we want to compare the average hotel room price in Irvine. Is that a significant difference from the average price in Anaheim? So that's our goal here. Like if you are some, hotel company, you want to, make a decision, say, do you want to build up a hotel somewhere, right? You want to do some market research, right? Remember the classic way to say location, 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 right? It is very, very important, right? So we want to see here, very simple. That is the average hotel room price from Irvine and from Anaheim. Anaheim, I would say, is that most likely because of the Disneyland, is that right? I mean, that makes that a place very special, right? Irvine is a place has a lot of business for the, a lot of companies, right? They have their offices in Irvine. So we want to compare, do we have any significant price difference, right, in terms of a hotel? Now we are given the standard deviation for the overall Irvine hotel room price is about $5.62. And then also given the standard deviation from all Anaheim hotel room price is $4.83. Everybody, what do we call this? Is it called, when they say, oh, that means what? Population standard deviation. We have 2 sigma here. You see, what did we learn before? We only have 1 sigma. In other words, we only have like, when we plug into the formula, that Z formula, right, corresponding to 1 sigma. Now we have 2 sigmas, right? And then to compare that, we also need a sample. So this case here, we have 2 samples. So sample 1, we got randomly selected 50 hotels from Irvine. Find out their average hotel room prices of $85.42. And then another sample from Anaheim happened to be also 50 hotels. Everybody, this number 50 could be different, not necessary to be the same as this 50, right? Could be 60 or any number you want, right? Also, those are the randomly selected hotels, right? Their average hotel room price in Anaheim, $80.61. So you can see from those 2 samples here, you can see the price. Yes, it seems like Irvine, out of those 50 hotels, we can say Irvine hotel room price is like $4.8 more, right? The question is, can we say that overall, right? Not only for those 50 hotels. Can we make a conclusion that overall, all the hotel price in Irvine is significantly different from Anaheim, right? Alpha is equal to 5%. Everybody, what's the confidence we are talking about? Confidence is 1 minus alpha, which is 95%. So we are going to do the 5 steps again, step by step. Number 1, write down what is H0, what is H1. Everybody, the same 5 steps. We only change the notation here. Now, since we have 2 samples, right? Two samples. In other words, you will have two average. One is the average from Irvine. The other one is the average from Anaheim. So H0, remember that's the always we say equal. Is that right? So when we say net mu1 is equal to the two average hotel room price in Irvine, mu2 for the Anaheim. So H0 will be, when we say significant difference, right, is equal or not. Everybody, you see that here? Because they say significant difference. They did not say is higher or lower by default, not equal. Follow me? So that's for H1 here. Okay, now that's the way to write down H0, H1. You can see the difference. Is that right? Previously, we just write down mu equal to some number we want to compare to. Like the average cost of a college, 5,700. Some number from the historical. Is that right? Here, we simply want to compare two sample average, like X1 bar here, X2 bar here. And those two sample average essentially representing two population average. All the price in Irvine, all the price in Anaheim. Are they essentially the same or different? Everybody follow me that, right? I put another statement here, or mu1 minus mu2 equal to 0. Everybody follow me. First, let's check. Can we say this mu1, if mu1 equal to mu2, can we say this direction is right? Right? Yes, I think that most people will say yes. Is that right? If mu1 equal to mu2, then mu1 minus mu2 is equal to 0. That's right, right? Now, how about the other way? This way. If mu1 minus mu2 equal to 0, can we say mu1 equal to mu2? Yes, right? So in other words, they do equivalent to each other, right? Why this one is important? Because later on, we are going to use something from here. Okay, so that's in the calculation coming, we are going to use the formula, right? Previously, when we are given 1 sigma, we are using the 1 sigma formula. You probably see this one, right? That's the one you are familiar. This one here, right? So I was trying to write down something like that. Everybody, let's check if they are equivalent or not, right? The numerator is the same. The denominator, a little bit different. I put the sigma into the square root. So we have a square here. You see the square and the square root got canceled, then there's the sigma itself. So you can see they do equivalent, right? So why do I put this way here? Because I want to write down in a similar way for these two sample z-test here, formula. Check out the formula here, what do we have? Compare with one sample case, right? Sample average minus mu divided by square root of sigma square divided by m. You check the denominator here. We have two standard deviation, two variance right now. Sigma 1 square, sigma 2 square, right? Divided by n1 here, divided by n2 here. You see, that's the purpose when I write on that way. Similarly, on the numerator, previously, we only have one sample average. Now, what do we want to compare? We want to compare the average difference. So we are writing x1 bar minus x2 bar, right? And minus the two average difference, mu1 minus mu2. Follow me? Previously, is only one number. Now, we want to compare the difference of those two average, right? So that's the new formula you will be given. Now, based on that, if we plug all the numbers, the sample average from Irvine, right, minus Anaheim. Be careful here, everybody. I put a 0 here, right? Why is that? Because H0 here. Remember, when mu1 equal to mu2, mu1 minus mu2 is equal to 0. In other words, this piece is 0. Is that right? Everybody? is not always 0. There will be an example coming, some other example coming, right? If I want to say the average price from Irvine is $2 more than from Anaheim, then in that case, we want to compare the difference, mu1 minus mu2 is equal to 2. We will have that example coming. And then the other numbers we plug in here, we find out 4.59. That's what we call test statistics. Everybody, so far so good? Now, let's continue. Step number 3. Using the p-value based on the test statistics, 4.59, right? So you draw the bell-shaped curve, 4.59, right? It turns out to be two-sided. Why is that? Because H1 is two-sided. That remind us when we calculate p-value, we have to cover both sides, right? So we got the probability on both sides and then double that. Be careful here, everybody. It's a little bit tricky. Because here we have, if you are trying to find out from the Z table for the 4.59 or negative 4.59, check that. If you can open that Z table, everybody, if you have the Z table printed out, right? We are looking for, what's the number? 4.59 here, is that right? Or negative 4.59. Check out this Z table. What's the most negative Z you can get? Is the most negative Z is negative 3.49. Like how about the negative 4 point something? Or how about negative 3.6, negative 3.5 something, right? Is out of here, it's not here. Similarly, what's the most positive Z you can get? You have 0, 1, 2, 3.49. How about 3.5 something, 3.6 something, 4 point something, 5 point something, right? It's not here. That means what? Are we in big trouble? No, we are still okay. Why is that? Everybody, I need your attention here. If you pay attention to this, let's start with the easy one. Negative 3.49, that's the most selective you can get, is that right? So negative 3.49 corresponding probability is what? 0.02%. So it's like 0.00002. Right? I think I said one more zero, right? So in other words, the probability here corresponding to 3.49 is like 0.02%. It's very small, everybody. 0.02% is less than 1%, is that right? It's actually less than 0.1%, right? This number here, right? So that's this area here, you can understand, right? Now, what if they are asking negative 4.59? In other words, is what? It's going further to the left. So say here is negative 3.49. I'm going even further. Negative 4.59 is like even small subset here, everybody. Now you see, even though I don't know what's exactly for this probability to the left of 4.59, negative 4.59 to the left, I don't know that. But I know it's smaller than this whole area. And what's the probability for this whole area here is what? It's 0.02%. So in other words, the p-value on this side here, this one side here, is less than 0.02. You see, that's the reason I write on the notes here is the probability less than 0.02%. Even if you double that, you see, you double that because two sides is what? Is 0.04%. That's still very small. Why? Because remember, alpha is usually what? It's usually 5% or 1% or 10%. In this case here, our question is 5%, right? So 0.04%. We know the p-value is less than that. Even though we don't know exactly what's the p-value, right? We don't know that, but we know p-value is smaller than this number. But then this number is even less than alpha. So you see that inequality here. So in other words, p-value is going to be less than 5%. Remember, what's the conclusion? If p-value less than alpha, what do we say? Reject, right? Reject what? Reject HO. So that's step number 4, right? So make a decision. We are going to reject H0. Step number 5. What does that mean? Using human being language, right? When we say reject H0, what does that mean? So reject H0, that means accept H1. H1 is right. Why do we care about H1? Because H1 is the claim. Check out, what's the claim here? The claim here is to say, is there any significant difference between those two cities, right, for the hotel room price? So H1 is right. There's a significant difference. We have 95% of confidence to say that. Follow me, everybody? So that's the 5 steps. Hypothesis testing using the one we just learned, right? So almost the same except new formula, right? Now we have 2 sample average, 2 population average. That's the difference. So that's our first example. We did go over a little bit slow. Example number 2 here, as we mentioned earlier, right? Now we know they are different. That's the conclusion we had previously, right? We can say we have 95% of confidence to say they are different. A follow-up question, easy, right? How much is the difference? Can we say the average price from Irvine is $2 more from Anaheim, right? People will usually out of curiosity, try to find out more, right? So for that one, we have to do hypothesis testing again, right? So 5 steps. Number 1, write down H0, H1. Everybody follow me? Now, H0 will be what? Previously, mu1 minus mu2 equal to 0 because we want to compare, are they essentially the same or significantly different, right? Now we want to compare is $2 more or not, right? So is that equal to 2 or bigger than 2? Follow me, everybody? So that is coming from the question, the claim, the statement, right? So that's to the right. We call this right tail test. The same, right? Now, step number 2, plug the numbers into the formula, doing the calculation. Be careful here, everybody. Previously, mu1 minus mu2 we replace by what? 0. Remember the example earlier? Let's go back, right? We replace here by 0 because H0 here is equal to 0, right? Now H0 here, we want to compare that, is that $2 or more, right? So we have to replace this one by 2. Follow me, right? So in other words, all the information is the same except that 2, right? So after you calculate that, you got different Z. Previously, if you remember, what's the number we got? 4.59, right? Now we got something different, 2.68. That's what we call Z or test statistics, right? Number 3, find out what's the p-value. So now we got this test statistics, the Z test, right? 2.68. We have to decide, is that this area or both, right? Determined by H1. Everybody, H1 is to the right, gradient. That means we only care about this area here, right? So you're looking for the which table to find out this probability? Z table, because Z formula, right? So we find out using a 1 minus that, or you can use negative 2.68 directly, right? So you find out it should be 0.37%. That's the p-value. Compare with alpha 5%. So p-value less than alpha, everybody asking yourself, p-value less than alpha, what do you say? Reject. Reject what? Reject HO, right? So number 4, make a decision, reject HO. Number 5, translate using human being language. When you say reject HO, that means what? Accept H1. Why do we care about H1? Because H1 is the claim. So H1 is right. The claim is right. We do have 95% of confidence to say the average hotel room price from Irvine is $2 more than from Anaheim. You see that, right? So we can say, number 1, the average price from Irvine is not only significantly different from Anaheim, right? Further, we can say it is actually $2 more than from Anaheim, right? Can we say even further? Like somebody out of curiosity, they say, can we say $4 more, right? Because what? Because if you check out the sample here, what's the dollar difference for those 2 samples, right? It's about $4.8 difference, right? So if the people they say for all the hotel room price, can we say it's about $4 more? I mean, potentially possible, right? We have to do 5 steps hypothesis testing, right? So in other words, we have to replace here by 4, and then recalculate, right? Doing those 5 steps. That's very time consuming. Is that right? That's very time consuming. Okay. So later on, we will introduce some other way to do that. Okay. So 5 steps hypothesis testing, we can do that. It just take some time. Okay. Before we go to the next one, I want to mention both samples, right? So 50 hotels from Irvine, 50 hotels from Anaheim should be randomly selected, right? You cannot select, like for example, 50 hotels from one corner of that city, right? Has to be, representative for that city, randomly selected, right? Number 2, those 2 samples must be independent of each other. What does that mean? That means if those 50 hotels from Irvine, all of them, they are like DoubleTree hotels, right? And also the other 50 hotels from Anaheim is also DoubleTree hotels. Then they are not independent. They are coming from the same franchise. So in that case, you are trying to compare the same franchise hotel, not overall hotels, right? Number 3, sample size here usually will require more than 30 samples to give us a better confidence. In other words, you can see the difference more clearly, usually. I mean, we have been through more than half of this semester, is that right? So we are stats professional. Later on, right, some people asking you, I want to do some test. I want to find out something different, right? What's the sample I need to get to compare, right? There's one magical number. You can always tell them, should be at least 30 samples. Okay, that give us the people some confidence. Now, the second piece, remember, we always want to use the confidence interval to see, can we actually get the same conclusion using a confidence interval, right? So it turns out we also have the confidence interval for the sample difference, for the population average difference here. So this confidence interval is trying to get the difference, right? Mu1 minus mu2. Previously, when we have this one sample here, we just have the sample average was the range, right? So the sample average minus something, sample average plus something. That's what we learned in chapter 7, right? Now we want to study the difference of these 2 population average, right? So we have a similar formula. That's what we call here the sample average difference, minus something and then plus something. You see? The formula here is very similar, very similar. I mean, not exactly the same, but it's very similar, right? So now we know we put all the information available we have here. Sample average from Irvine, $85.42. From Anaheim, 80.61. Sigma 1, Sigma 2, N1, and 2. We put all the information into the formula. Everybody? Z alpha divided by 2 is what? Determined by what? What's the confidence, right? The confidence we mentioned earlier, we are talking about 95%. 95%, right? 95%. If it's not mentioned by default, 95%. So in that case here, we find out 1.96. Use that number to find out 95% of the time. The range is between $2.76 to $6.86. Everybody, I want you to pay attention to the following 2 to 3 minutes here. It's very important here. Now we know 95% of the time they are in this range, right? We can draw that here, right? So it's about $2.76 to $6.86. That's the difference. Is that right, everybody? That's the difference. That's the difference. They are 95% of the time, they are all in this range, right? Now, we want to compare, for example, the null hypothesis, the average price from Irvine. Is that the same as average from Anaheim? That means what? We compare with 0. Is that right? They are equal, right? That's the, or not, or bigger than 0, right? But that's the 1, 0 here we want to compare to. Everybody? So 95% of time, here we have between 2.76 and 6.86. Is it right? So that's 95% of time. Okay. Can we say there's no difference between Irvine and Anaheim? Means they are equal. Everybody? You type your answer on the message box, right? So can we say, now we say 95% of the time, the price difference is between $2.76 to $6.86. Can we say the price difference is 0? That means, like, can we say the price from Irvine is the same as Anaheim? No, right? Because 95% of the time is like $2.76 more than from Anaheim, right? So in other words, 95% of the time, that's a significant difference, right? That's the one thing I want you to understand that, okay? Now, there's even more tricky part here. Remember, previously, we want to compare is like $2 more or not, is it right? Where's the 2? 2 is like somewhere here, is it right? Okay, so this is a little bit tricky here. Everybody, pay attention to the following statement. If this statement is true, if you have $100 more than me, if that statement is true, okay, can I say you have $10 more than me? Can you type your answer on the message box? One more time. This statement, say you have $100 more than me. We know that statement is true, okay? And then can we say you have $10 more than me? Yes, right? Right, I see a few people type yes, right. Similarly, now we know 95% of the time, the Irvine is $2.76 more than more from Anaheim, is that right? That's the lower limit, $2.76 more from Anaheim, 95% of the time. Can we say 95% of the time, the Irvine is $2 more than from Anaheim? Type your answer on the message box, everybody. Is that yes or no? So one more time, 95% of the time, Irvine is 2.76 more dollars from Anaheim, right? Can we say 95% of the time, Irvine is $2 more than from Anaheim? Yes, is that right? The same logic as what we mentioned earlier, right? Say if you have $100 more than me, say that's true. Then we can also say you have $10 more than me, right? That's the same logic here. Okay, so you see, based on that confidence interval, we just made a hypothesis testing confidence, is that right? Say, number one, we know they are different. They are significantly different from each other. So we reject H0. Is that right? Based on that confidence interval. Not only that, we also reject, when they say $2. So we know from that confidence here is what? It's 95% of the time, it is $2 more. Is that right? Now, further, remember in the previous question, we say, can we say $4 more? Remember? Is that right? So in the hypothesis testing, we have to do the 5 steps again. But using the confidence interval, it turns out we can also make a decision from here. Where's the $4, everybody? $4, that's somewhere in the middle. Follow me? Right? So if we are trying to say 95% of the time is that $4 more, then it is a little bit tricky here. Why? Because that 95% here, right? Sometimes this area here, they are less than $4. This area here is more than $4, but it's not 95% of the time. Maybe like 40, 50% of the time, but it's not all the 95%. You see? So in other words, we cannot say 95% of the time, the Irvine is $4 more than from Anaheim. Everybody follow me? So you see how powerful it is for this confidence interval. It turns out this one is really, really useful in the industry. So that's the one. I hope that you understand that, and later on, if you can apply this in your work, right? Some of you may work in the industry, you will see the confidence interval. I'm pretty sure. All right, so that's for this 9.1 here. In terms of 2 sample average, let me erase that. 2 sample average, we want to use the hypothesis testing to compare that.